All right, let's dive in. Today, we're going to talk about how to make our applications feel truly alive. We're moving beyond just waiting for a user to click something. We're talking about creating animations that have a life of their own, all driven by the simple passage of time. So let's get started. When you think about it, most apps are pretty passive, right? They just sit there and wait for us to do something, like click a mouse or press a key. But what if we want more? What if we want a shape to just glide smoothly across the screen, or a sun to set in the background, all by itself? How do we get an app to act on its own without waiting for our command? Well, the answer lies in something I like to call the animation's heartbeat. It's an event called OnStep, and it is the engine that's going to drive our application forward, automatically and repeatedly. It's a real game changer. So what is this OnStep thing really? Just think of it like a constant, rhythmic pulse for your app. The CMU graphics library calls this function for you, over and over and over again, and you don't have to do a thing to make it happen. Each time it gets called, your app takes one tiny little step forward in its animation. Maybe a circle moves 1 pixel to the right, or a square gets just a tiny bit bigger. And this creates a continuous, kind of never-ending loop. As you can see here, a tiny fraction of a second passes, and that triggers the OnStep event. Your code then makes a small update, and bam, the cycle immediately repeats. It's this super rapid repetition that tricks our eyes into seeing smooth, continuous motion. Just how fast is this heartbeat, you ask? Well, by default, CMU Graphics calls on OnStep about 30 times every single second. That's our baseline tempo, you know? It's the standard rhythm for any animation we create right out of the box. Okay, so 30 steps a second is a great start. But what if you want more control? Maybe you're building a racing game and you need to speed things up. Or maybe you want a cloud to drift lazily across the sky and you need to slow it way, way down. This brings us to our next crucial tool, controlling the speed. And the solution is a property called app.steps/second. I want you to think of this as, literally, your animation speed dial. You can set this property to tell CMU Graphics exactly how many times you want OnStep to be called each second. It gives you direct command over your app's tempo. So let's see what that actually looks like. If you set app.steps/second down to something like 10, things are going to move pretty slowly, very deliberately. At the default of 30, you get that standard, smooth animation we talked about. But if you crank it up to 60, well, you'll get much faster, more fluid motion. The control is completely in your hands. But there is a catch. You can't just set this to 1,000,000 and expect light speed animation. Your computer's processor, your CPU, and whatever other apps are running, they create a bottleneck. Realistically, the fastest you can probably go is somewhere between 50 and 100 steps per second. If you set it any higher than that, it probably won't have any effect. So now that we have things moving quickly, we run into a totally new problem. How in the world do you debug something that's changing 60 times a second? An error might flash by before you even have a chance to see it. And this is where pausing and stepping become absolutely essential tools. I mean, without the ability to pause, finding a bug in an animation is like trying to photograph a specific hummingbird's wing beat. It's just not going to happen. As this quote points out, you really need to be able to freeze time to see what's really going on at one specific moment. So, how do we build our own pause button? It's actually a really simple 3-step process. First up, we add a new variable to our app, something like app.paused, and we set it to false to start. Next, we set up a key press, P is always a good choice, to flip that variable between true and false. And finally, and this is the most important part, at the very top of our OnStep function, we add a little check. If app.paused is true, we just return immediately, skipping all the animation code. It's that simple. Pausing is incredibly powerful, but we can get even more precise. What if you've paused your app right before a potential bug happens and you want to watch the very next thing that happens in extreme slow motion? How do you advance the animation by just one single frame? This solution requires a clever little bit of code organization. First, we're going to create a new helper function. Let's call it takeStep. Then we take all of our animation logic, the code that actually moves the shapes, and we move it out of OnStep and into this new takeStep function. Now our OnStep function is super simple. It just calls takeStep as long as the app isn't paused. But here's the magic. We can also set up another key, like S, to call takeStep directly. And this gives us the amazing power to manually advance our animation one frame at a time. All right, let's pull all of this together. We've just assembled a seriously powerful set of tools for controlling the flow of time inside our applications. This is your brand new animation toolkit. So let's do a quick review. You've got OnStep, that's the fundamental heartbeat. You've got app.steps per second, that's your speed dial. You've got app.pause, the essential pause button for debugging. And finally, that take step helper, which gives you that super precise single frame control. This is pretty much everything you need to create and meticulously debug any dynamic animation you can dream up. And this right here is the crucial takeaway. You are no longer just building apps that react. You can now create entire worlds that live, breathe, and evolve all on their own. You can control their speed, you can pause them at an instant, and you can inspect them frame by painstaking frame. You are now a master of time within your application. So the only question left is, what are you going to create with that power?